Good afternoon, dear students. After deeply looking into the oxidation reactions, now we are continuing the same topic, and the next point is reduction reactions. In previous lectures, we had seen the Bayer-Villager oxidation and Oppenauer oxidation reactions. In Bayer-Villager oxidation reaction, a ketone undergoes oxidation in presence of peracid or peroxide to form an ester, while in that of Oppenauer oxidation, and when a secondary alcohol reacts with acetone in presence of aluminum isopropoxide, then it gives to you a ketone. This was the Oppenauer oxidation reaction. Now, looking into the chemical reactions and mechanisms of both the reactions, today we will continue the next point, that is reduction reactions. In case of reduction reactions, what is reduction reactions? The addition of hydrogen is known as reduction reaction. Also, the removal of oxygen is known as reduction reaction, or the addition of electrons is also known as reduction reaction. So for your syllabus, there is just addition of hydrogen is known as reduction. This is the concept, and this can be applied in the upcoming reactions. There are 4 reduction reactions that can be studied in this lecture, and those are MPV reduction, Clemmensen reduction, reduction using LiLH4, that is lithium aluminum hydride, and reduction using sodium borohydride. All these 4 chemical reactions are used for the reduction purpose, and after oxidation, now we will continue the reduction reactions. The first reaction is Meerwein-Pandorf-Verley reduction reaction, that is MPV reduction. It is known as MPV reduction. Note down that this reaction is exactly opposite to, or occurs in reverse manner to that of Oppenauer oxidation. This reaction is exactly reverse of Oppenauer oxidation, or this occur exactly in opposite manner to that of Oppenauer oxidation. So what is the reaction? What is the reaction? Now see here. In case of MPV reduction, when a ketone reacts with a secondary alcohol like isopropyl alcohol in presence of aluminum isoperoxide, then it gives to you an alcohol, that is secondary alcohol, and a ketone. In this reaction, the product of Oppenauer oxidation reaction is reduced back to alcohol. So this is exactly reverse of the Oppenauer oxidation. It was the general reaction that is to be shown. It is the general reaction that is to be shown here on the screen. Then I will take an example of this reaction when 2 butanone undergo reduction with an alcohol, that is isopropyl alcohol, in presence of aluminum isopropoxide, then it gives to you 2-butyl alcohol, or as isobutyl alcohol, or means it as 2-butanol. then it gives to you 2-butanol along with acetone. This is the reaction or an example of the MPV reaction. In this manner, you can take another examples also, and you can go through the books for further examples. Now, the next is mechanism. What is the mechanism of this reaction? The mechanism is as shown below. In the first step of this reaction mechanism, the alcohol coordinates with the aluminium of aluminium isopropoxide to form an intermediate aluminium complex. In second step, this aluminum complex is deprotonated by an alkoxide ion to form another alkoxide ion. And in the third step, both alcohol and acetone are bound to aluminium, and hydride ion transfer occur from an alpha carbon of an alcohol to carbonyl carbon of acetone via 6-member transition state to form desired ketone. This is the mechanism of this MPV reaction. See in mechanism. Initially, the secondary alcohol, that is isopropyl alcohol or 2-butanol, in this case as per our example, 2-butanol is now coordinated with the aluminium complex, or that is aluminum isopropoxide. Now one of the isopropoxide anion is departing from the aluminum complex, and this new alcohol is coordinating with the aluminium. Now in the second step, the proton of the alcohol now has been lost, and there is formation of isopropyl alcohol. There is formation of an isopropyl alcohol and aluminium complex, that is intermediate. Now this aluminium complex intermediate coordinates with another ketone, that is acetone, to form a 6-membered chair-like transition state as that of in the open oxidation state, and there occurs the intramolecular rearrangement, and there is formation of an intermediate, and this intermediate decomposes to give to you a ketone and an aluminium complex. Now after hydrolysis, this aluminium complex gives to you an isopropyl alcohol or a secondary alcohol. This is the general mechanism of the MPV reaction, and this is also the mechanism of same but in the direction, the mechanism of open oxidation. Both you can relate to each other. After MPV reaction, the next reaction is Clemmensen reaction, and in this Clemmensen reaction, what is happening? When a carbonyl compound, an aldehyde or ketone, undergo reduction with zinc amalgam and HCl, then it gives to you carbohydrate. Sorry, it gives to you hydrocarbon. Then it gives to you hydrocarbon. It means in this reaction, the carbonyl group is selectively being converted into a hydrocarbon group by using zinc amalgam, that is zinc mercury and HCl. So this was the general reaction. Now particularly when we are looking for the examples at that time, here is the 1-phenyl ketone, that is we may say it as ethyl benzophenone. You can see it as ethyl benzophenone. Now this reacts with, or this undergo reduction with zinc amalgam and HCl, and then it gives to you N-propyl benzene. This gives to you N-propyl benzene. Now see, in this reaction, ethyl phenyl ketone undergoing reduction with zinc amalgam and HCl, and it is giving to you N-propyl benzene. So it was a general reaction, it was one of the examples. The second example is of aldehydes. In case of aldehydes, 2-cyclopentyl acetaldehyde undergo reduction with zinc, mercury and HCl to give ethyl cyclopentane. Keep in your mind the names of the compounds. I didn't wrote here or mention it here because due to time problem or due to some technical problems I couldn't write here. You can note the names of the compounds and go through it. I have told you the general reaction, and these two examples are here. Write down these two examples and also find similar examples through your reference books. Then the next is mechanism. This is your Clemmensen reaction, and the next is mechanism. In case of mechanism, what is happening in this case? In first step, the oxygen atom of carbonyl group carries 2 lone pair of electrons, which abstracts one of the proton from the HCl, and it forms a oxygen cation, which initially breaks bond with the carbon, and now there is formation of a carbocation. But there is also present a zinc atom is also present. Now this zinc atom donates a pair of electrons to the carbocation, and there forms a bond in between the carbon, and there is formation of a bond in between the carbon and zinc. Now in the next step, another proton from another HCl is abstracted by the lone pair of oxygen of hydroxy group, and there is loss of water molecule to form a new carbocation in the next step. Now there is formation of a zinc carbocation complex, which now breaks bond with chlorine, and the electrons are shifted to the carbocation, so that carbocation undergoes reduction, and then there is formation of a carbanion. Now this carbanion, that is zinc carbanion complex, undergo protonation, and then in the next step the zinc breaks the bond with carbon by donating the electrons to the carbon, and now there is formation of another new carbanion. Then in the next step, the carbanion abstracts another proton to form a hydrocarbon group. This was the mechanism of the Clemmensen reaction, and now see, this Clemmensen reaction has two parts of mechanism. One is carbanion mechanism and another is carbene mechanism. So for our syllabus I have taken the carbanion mechanism for because it is simple and lucid. Otherwise the carbene mechanism is hard, so that for your sake of convenience I have chosen to teach you by the carbanion mechanism path. Now the next is reduction using lithium aluminum hydride. Now see, the lithium aluminum hydride is a strong reducing agent. It is a strong reducing agent, and it almost reduces all the functional groups. Except only the functional group that is not reduced is a conjugated diene system. A conjugated diene system is not reduced by the what is it as this lithium aluminum hydride. So otherwise it could reduce all the functional groups. So it is a strong reducing agent. It will reduce carbonyl functional group to an alcohol by hydride transfer mechanism. So see the first reaction, that is reduction of a ketone by using lithium aluminum hydride. In this case, 2-butanone undergo reduction with lithium aluminum hydride followed by hydrolysis to form 2-butanol. See here, there is removal of or breaking of one of the carbon oxygen bond and formation of oxygen hydrogen bond. It means there is addition of the another 2 hydrogen atoms. So when 2-butanone undergo reduction with lithium aluminum hydride, then it gives to you 2-butanol. This is the first reaction. For your convenience, I have taken 2 to 3 examples. The second example is reduction of a carboxylic acid group. Now see here, a carboxylic acid undergo reduction with lithium aluminum hydride to form an alcohol. For example, when acetic acid undergo reduction with lithium aluminum hydride, then it gives to you ethanol. It is the example. Then the next is also reduction of ester. In this reaction, when an ester undergo reduction with lithium aluminum hydride, then it gives to you 2 alcohols. One is from carbonyl part, another is from alkoxy part. So there is formation of 2 alcoholic products. So for example, if we took an example of ethyl benzoate, at that time ethyl benzoate undergo reduction with lithium aluminum hydride, then it gives to you benzyl alcohol as one product, and another product is ethyl alcohol. So not done that reaction also. In the next reaction, when we are talking about the selectivity of the lithium aluminum hydride, at that time lithium aluminum hydride can reduce any group, any functional group of organic chemistry. So look at this reaction, last reaction, when this compound, and its name is 1 2 3 4 5 6, when this methyl 4-carbaldehyde pentanoate undergo reduction with lithium aluminum hydride, then it gives to you a diol. Along with the product of methanol. And the diol is 1,5 pentane diol. So all these are the reduction reactions. You can practice all these. Then the next is mechanism of the reduction by using lithium aluminum hydride. It involves just 2 steps, and this is a very simple mechanism. In the first step, there is nucleophilic attack of hydride ion on the carbonyl group. So see here, the carbonyl group is undergoing attack of the hydride ion, that is from lithium aluminum hydride. One of the hydride attacks on the carbonyl group, and there is formation of oxyanion. Now this oxyanion is in the second step protonated with water to form an alcohol. See here, the alkoxide is abstracting the photon from the water to form alcohol and lithium hydroxide. This is the mechanism. This is a just 2 step mechanism. First is nucleophilic attack by the hydride ion. The second step is protonation of alkoxide. Now the next is reduction using sodium borohydride. In this reaction, when benzaldehyde undergo reduction with sodium borohydride, then it gives to you benzyl alcohol. Keep in mind the names of the compounds. It is very important. You can also keep in the mind the chemical reactions, but you may also remind the names of the compound, so it could be better to understand the chemical reactions. So when benzaldehyde reacts with sodium borohydride and in presence of sodium borohydride and methanol, then it gives to you benzyl alcohol. This is the reaction of benzaldehyde to reduce to benzyl alcohol. Now the next is when butanol undergo the reaction with sodium borohydride, then it gives to you butanol. This is the another reaction of conversion of an aldehyde to alcohol. Next reaction is includes, the example is an ester, aldehydic ester. This aldehydic ester undergo the reaction with sodium borohydride to form an alcohol. Now here see the selectivity. In case of lithium aluminum hydride, both the groups were reduced by the lithium aluminum hydride, because lithium aluminum hydride is a strong reducing agent. But in this case, sodium borohydride only can reduce carbonyl group. It cannot make any changes in the ester group. So ester group remains as it is in the product, but the aldehyde group has been converted into an alcohol. So this is the selectivity of sodium borohydride, but there is no selectivity in case of lithium aluminum hydride. Now the next example is conversion of a ketone into alcohol. Now see here, this 2-pentanone undergo reaction with sodium borohydride to form the 2-pentanol, This is the another reaction, another example. So after looking into all the 4 examples, now the next is mechanism of reduction reaction by using sodium borohydride. Now the see here in the mechanism. In this mechanism, there is slightly complicated because one of the proton from the alcohol is being extracted by the carbonyl oxygen to form an alcohol, and there is formation of sodium methoxyborohydride, an intermediate complex. But we will see a simple version of this as that of in the reduction case of reduction of compounds by using lithium aluminum hydride. This reaction also involves 2 steps. One is nucleophilic attack by hydride ion, and here is the attack. The hydride ion attacks on the carbonyl carbon of the ketone, and there is formation of a sodium salt. Now this sodium salt of alcohol abstracts one of the proton from the ethanol to form the alcohol, and there is conversion of a ketone into alcohol. This is the whole mechanism. The first step is attack of nucleophilic hydride ion on the carbonyl carbon, and the second step is abstraction of proton. These 2 steps are involved in the reaction, that is reaction by using sodium borohydride. You can go through all these reactions and try for the understanding these reactions. So up to that, thank you. We will see in next